Hello everyone, my name is Odarike Charles and today I'm going to show you how to find or visualize the input and output characteristic of a transistor using Python and also how you can be able to simulate it on LTspice and visualize the input and output characteristic. Maybe you are doing a project and you want to visualize the input and output characteristic. For Python, it's it does not require much because if you have the approximate equation of the model, then you can be able to simulate the input and get the output characteristic. So from the Python, I have this script in the video comments and you can be able to head to my GitHub account and you can be able to clone and have a look at the code. And also I have the simulation on LTspice so you can be able to get the file, go and run it on LTspice and have a look at it. So what I've done, just I've used an approximate model of the using exponential. So this is the approximate model. So you'll find that the result that we're getting here will not be really the same to the spice to the LTspice simulation. So you can be able to see that the input characteristics, as well know, for a transistor or a diode, the current will start to flow when the voltage at the base exceeds 0.7 volts. And from the simulation, it has already showed that the current will start to flow when the base voltage it's about 0.7. This one should be VB, no problem. So I'll have to change that. So here you have the output current and output like we term it as current at the collector and the voltage VCE, the voltage or at the collector emitter. So we plot it and we see that a different current at the base, we can see how fast it reaches the saturation current, whereby there's no change in the current in the collector. So from that, let me head to LTspice and show you how it can be simulated. So this is the LTspice. I can press Control N to get a new one. So I go to Components, I'll pick NPN, place it there. I need a resistor, place there. I need a base resistor, I can place it there. I need a voltage VB, I need a VCC, so I can be able to connect everything. Just simple like that, like that. Then I need a ground hit there. Move it a little bit there, then I can wire it there. So this is the schematic, very simple. So from this now I want to name, so this one I can name it as this resistor 1. This is the resistor at the base. So resistor 1, I'll have a value maybe 1k ohm. Resistor at the base, let me have it just 330. And voltage, because I'm starting with the input characteristic, let me have a voltage of 5 at the VCC. So I can name it VCC. Then I can name this RC. Then I can name this one RB. Then now I want to choose a model. So you right click at the NPN transistor. So I right click there. Then I can be able to pick a model. Let me use the simple one, the 2NN, 2N222. So then I'll vary the voltage at the base from 0 to 5, and let me say just from 0 to 1, and I'll be incrementing the value with the 0.1 so that I can see how it flows. So I can come here to configure, or you can use A for shortcut, then DC sweep, we have input, let me call it VB, like that. Then I can have the value as 0. Let me have the first value as 0 so that it doesn't interfere with the simulation. So it will be increasing from 0, 0.1, yeah, up to 1. So here comes to DC sweep VB, the input is VB, VB. Then the increment is linear, type of the sweep is linear. Then I can start from 0 to 1 to 0.1. So you can see it generative for the spice directive. So you can place it here. So after that, now I can be able to run the simulation. Yeah, here it is. So we can be able to see if you want to get current, you attach you place the cursor. Let me call it a cursor on the resistor. You get that current, but you can see the current is not what we expect. So it is in the reverse direction of what we want. So what I'll do, I'll add a plane, then I'll add a trace, of which I'm going to multiply it with -1. So I of RB. So I get that plot. So I can do away with this plot here. So I can delete. Yeah. So you can see that current will start to flow until we get to a value. Let me have a cursor. Let me add a cursor. The current will start to flow when we reach around the value of 0.7. So that is the input characteristic that you can be able to see. So for that, this is the way you can be able to simulate and get the input characteristic. Yeah. So let me save this first so I can be able to save us. I want to save this so I can save us. Then desktop where I work is workspace. Then BJT so I can have another folder here. I call it simulation. Then inside I can say LTspice. So if you go to LTspice, you get that LTspice simulation. So after that folder, now I can say just input characteristic. Yeah, so I've said that. So this is how you can be able to simulate the input characteristic. So let's see how we can now generate what the output characteristic. As from the simulation, you saw that the output characteristic look like this. So we want to see if you can be able to use LTspice and get such kind of upload. So to get that, now I want to vary this one from 0 to 5, but vary VCC, like vary, this one will just remain like this, but now what I'll do, I'll sweep it from 0 to 0.5 to 5, then I'll have an increment of 1 so that I can have 5 plots. So like that. So this one, I want it to increase from 0 to 5, but with an increment of 0.1. So I can have that as 0. So I can come to this. Now I want to add another source here. So to add another source, I come to this VC. So we have here, we add another source called VCC. And start value 0 and value is 5, then you have an increment of 0.5. So if you run this, you can see that we are obtaining this. But now I want to have VCC to start, then VB to be the next. So VB will be the one that is varying, but the other one just to maintain so that you can get 5 plots. So I can come to, I think, am I doing the correct thing? Let me see. I think I'm having a problem. Let me have it as 1. Yeah. Let me have it as 1. Sorry. Yeah. Yeah. Like this. So let me have the value of VB to vary with 0.1. If VB varies with 0.1, good. So you obtain 5 plots. So 1, 2, 3, 4, 5. So at At 0, you can see there's nothing that's flowing. At 1, at 1, there's something that's flowing. At 2, at 3, at 4, at 5. So this is the output characteristic. So if you come to our simulation, you can see there's a relationship with what we simulated using Python. Now, this is what you have seen using LTspice. So this is the way you can be able to simulate. Very, very simple. And I hope you have gained from this. So please subscribe to my YouTube channel. Thank you.